Yeah, good afternoon, everyone. Welcome, to my talk, Animating Patterns in a Pandemic. As Paul said, my name is Sam Bark. I work for Esri UK as a cartographer. And today I'm just going to be talking to you about a project that I worked on last year. Basically, we looked at COVID-19 data and how we can animate that and reveal different spatial patterns. So yeah, I'm just going to kind of walk you through the journey that we went on and then obviously show you what we made. If my PowerPoint catches up. So yeah, just a bit of a background, I guess, on me and the project. So yeah, again, as Paul said, one of my roles as a cartographer is within the Media Maps team, and that essentially focuses on creating public-facing maps for national press and sort of large audiences. So for us last year, I guess when the pandemic started, there was a lot of, for me, I naturally gravitated to looking at the different maps that were being created about COVID-19. And I think we've probably all seen hundreds of different versions of the same COVID-19 map, looking at cases, deaths, vaccinations, and some have been really good and, some perhaps less so. But it was really interesting to me. I kind of observed a bit of an evolution of cartography over that 18 months. And my sort of perspective, I saw a definite improvement and an increase of priority of cartography in the national press. And kind of let me explain what I mean by that. I think, and again, maybe this is just my perspective, but I think when I first saw a couple of the maps, we're talking February, March 2020, this is kind of one that caught my eye. It's obviously early days. We can count on one hand how many cases we've had, but it's definitely a very simple map. They've used sort of the number of values of COVID cases, different geographies in a choropleth. But, at the time, using the values kind of made a bit more sense. As you can see, there's only 85 in total. And we saw this on a couple of other maps. So that one was the Express, and this is the BBC. So again, this was number of cases outside of China. And what they've done is they've used those values in a choropleth map, which there's a couple of limitations to that. I think by using that choropleth and then putting a value on that, it can mislead the audience a little bit and make it really difficult to compare two different areas, because they've got vastly different populations and land sizes. So Luxembourg versus Russia is a pretty unfair comparison when you're looking at choropleths and values. So that was kind of some of the earlier maps that I saw. But then the BBC kind of shifted a little bit away from the choropleths and values towards using proportional symbols, which I thought was a really good switch. So it kind of meant that they could still use number of cases and an actual value, but obviously it was presented in a different and more easier to sort of compare style, cartography style. And I thought this was a lot easier to understand. And then again, there were, I found a bit more of a pattern between, newspapers using like weekly cases per 100,000 or a percentage change rate, and then applying this to a choropleth. And obviously there's a lot more going on this map, and we could probably critique all of the maps, but I thought it was good to see that, that progression from, the first couple of maps that I show you to these kind of choropleths, which I think have a lot of depth to them and a lot of information that you can pull out of them. And then I guess the final one I want to show you is this kind of COVID-19 per 1,000 residents by MSOA. And for me, this feels like the expectation when I'm looking at, a map in the newspaper now, a coronavirus map, because it feels like, that normalized rate and that choropleth it's good to feel like that's expected. And a lot of people now understand that. Whereas I think 18 months ago, from my perspective, I think there wasn't a high enough priority on creating maps with that intention. So just to kind of explain where I'm going with all of this, the kind of idea that we had in the team was, well, we want to create, I work for Esri UK and we create maps, and we want to kind of throw our hat in the ring, but we didn't want to go down the proportional symbol route or choropleths, because as you can see, they've been done far and wide. So what we wanted to do was do something completely different, something we haven't seen a lot of. And that kind of ended us up on using a dot density symbology style. So for those that aren't familiar, dot density it's a symbology style that allows you to represent quantities in polygons on a map. So for example, you can have one dot on a map and it equals a specified value. So, that could be one dot equals one person, or one, in our case, one coronavirus case. But it can be anything. It doesn't have to be 1 versus 1. It can be 1 dot equals 100 people or 1,000 people. And this is a really good example of a dot density representing population of the US. So for me, it's a really nice visualization style because you can see patterns quite clearly. And it's just a very kind of visually immersive sort of style that I definitely lean towards. So we kind of came up with the idea of using this visualization style. So the data that we were going to use, obviously we went to the government data. I think a few of you are probably familiar with this dashboard on the government website. This is obviously the sort of valid source of information when it comes to this subject. And actually, if you look down here, you can actually download the data. So you can go in, choose a specific geography, local authority, region, national, and then download a CSV of that sort of time frame. There's also another option to use the API, the government API, to extract that information. And again, those that aren't familiar, an API is a way of requesting information from a service and then pulling that out, and it makes it a lot easier to automate it and kind of to retrieve that information on a regular basis. And that's exactly what we did. We created a script that essentially every day pulled out that information through the government API and then updated it in a spatial sort of database, spatial layer here, which is now hosted on the Living Atlas. So you can see at the bottom, we've got 3 different geographies, so local authority, regions, and nations. And this is still to this day is updated every day. And what that meant for me was, I have the data ready to use in an Esri format, and I had the visualization style. So just had to merge the two then. So to kind of walk you through the cartography, I guess there's quite a few decisions that I made along the way. So I just want to kind of walk you through them. For me, when it comes to designing a map anyway, I tend to lean towards the less is more approach. I much prefer a more simple, minimal kind of map. But in this scenario, I realized that we were going to be throwing, thousands of dots on a map at the audience, and it could be quite overwhelming if we then started having, roads, rivers, boundaries. So the first thing for me was to get rid of everything, just keep it really clean and just keep the outline of the UK. And I did this in the vector tile style editor, which makes it super easy. So this was the output. So as you can see, super clean, very simple, just some nice neutral colors, the blue and then the kind of sandy color for the land mass. So the next thing to think about was the color choice. And this is always a tricky one for me. I always spend far too much time trying to decide my colors on my map. But for this one, I think that, the first instinct when you're choosing your color is, okay, what looks nice against my base map? What kind of balances out the other colors on the map? And, I naturally gravitated to from working from left to right, just the first couple of colors, the pink, the blue, and they look really great against that base map color. But one of the things we were quite conscious of when, displaying quite sensitive data about coronavirus is we don't want to kind of have a color that is completely left of field. We wanted it to feel like it was associated with the data. And I think that's quite an important thing anyway in cartography, to make it feel like the color choice is related to the data. So by having a pink map or a blue map, it just didn't feel quite right when we displayed it in a dot density. And then when we sort of had the same idea for the green, it kind of looked like a bit of a petri dish, which was the furthest thing from what we wanted to display on our map. So we avoided those 3 colors. So then just moving on to the final 2. So I think typically whenever people design a map, it's quite easy to sort of gravitate to using a bright red color because it's such an eye-catching color to use, and it really does capture people's attention very, very quickly. And for me in my role, one of the I guess the trade-offs is trying to capture people's attention on a national press scale, wide audiences, but at the same time trying not to play upon that sort of emotional color. And with red, it's got connotations of danger and sort of death. So we didn't want to use that to our advantage just to capture people's attention. So we then kind of ruled out the red color. And we landed on the orange because we felt like the orange still had that safety element to it. So the kind of warning sign where you see in between a green and a red on a traffic light, or the orange lights on a safety vehicle. And we felt that using orange was kind of somewhere between kind of capturing people's attention, but actually not playing on people's sort of that emotive color. So that's how we ended on the orange. But I as with all colors, it's very subjective. That's just kind of the thinking behind it. So this is kind of what it looked like. And I'll admit, when I first had the idea to do a dot density, it was going to be a static JPEG image. And it was just going to be, the total number of cases over, a year, essentially, all on one map. And I quickly realized as soon as I did that, it turned into a bit of a choropleth map. There was so many dots on the map and it just didn't work. And obviously it was never going to work. So this was just kind of, just got a nice zoom in here. This was kind of the visual that we agreed upon and we settled on. But then the next stage was to kind of break that out into individual days and create an animation from it. So before I touch on the animation stuff a little bit later, just a couple of considerations that kind of went through, that we went through when deciding on how to sort of create the final visual. So there's kind of two different techniques to using dot density. And the one on the left here with the urban mask label, this is called a asymmetric dot density. And this is where you draw, your dots are randomly allocated within your polygon. That's just how dot density works. But then you can further restrict that to an urban area mask or an urban area extent. So your dots are then only drawing where people actually live. And so in this example, using coronavirus cases, we wanted to map, as accurately as possible, but they're going to be randomly allocated. So we might as well include them in the polygons where people actually live. And so, we designed this and, this is definitely the more accurate version than the one on the right. But when it came to exporting both of them, the one on the left took about an hour to export that single frame. And on the one on the right took about 15 seconds. So the difference between the two was massive. And, we've all got deadlines. We've all got things, sort of targets to meet. And so when we were looking at mapping, I think it was 342 days or frames. You can do the maths. I don't think I've got the patience to kind of go through that approach. So we made a compromise on this one. Whilst in an ideal world, we'd have used the urban mask, we went for the no mask approach because we still felt it represented the data in a true fashion, just not as accurately as the one on the left. So the animation, this is what the animation created. We used ArcGIS Pro's animation tools, which are amazing for creating, these kind of visual styles. We made a decision at the time of creating, so this was December last year, we made the decision that a dot should appear on the map and disappear after 14 days. At the time, that was the isolation period here for the UK. And we felt like typically there's obviously a case-by-case sort of basis. Every case is unique, but this was the way that we felt represented the typical time somebody had a COVID-19 case. So that's the approach that we went for. And as you can see, it kind of looks cool. It's got a really nice visual. Actually, it doesn't make a whole lot of sense without any narrative around it or explaining the data. So the next step here was we've got the visual, we just need to take it one step further. So enter keyframes. So within the animation toolbox, there are these things called keyframes, which I've already sort of mentioned a couple of times. They essentially allow you to create a narrative to help explain the data. And what I mean by that is you can see along the bottom, this is my sort of animation timeline. And these are individual keyframes. And for every one, something happens in my map animation. It's either I pause the animation to draw attention to a certain bit, I add in extra explanations, a title, etc. And as you can see, these are, you can add text, time, and statistics to improve your map. So you can see that this is from the drop-down menu. You can add loads of different things, obviously a title, image, if you want to add your logo. But the thing that we really focus on is the map time and the map range. So for this map, a map time was so important to know whether you're in November or July. That was kind of the most important thing to understand. And then also the map range, what we did was add statistics to dynamic statistics to basically guide the user, the audience along with the map. So to understand the number of cases as the map was then showing that. So these are the two things that we really focus on adding. And as you can see, there's sort of many different elements to our keyframes. There's 28 in total, I think. And just to show you a couple of examples, these are the keyframes, that just some of them that we pulled out. So you can see we've got the date in the top left-hand corner with the title. Obviously, this dynamic text, accumulative cases, then updates. And then we have these sort of regular key events that happen. Schools and universities returning, a place went into lockdown, Leicester went into lockdown, the national lockdown, for example. We wanted to draw people's attention to this. And we realized we had a 20-second animation. And if we just threw all of this data at somebody without pausing, it was just going to be too overwhelming. So at these key spots, we paused the animation, let people kind of digest what they were seeing, understand the spatial patterns, and then we carried on and then moved on. So I think it's also worth talking about for full transparency, talking about some of the limitations. So when designing the cumulative cases dynamic text, the statistics counter, we wanted to create this sort of as accurately as possible. And if we wanted to do that, it would have needed to, because this was looking at a national data set, national layer. So it was looking at the cumulative cases for the whole of the UK. And then the map was showing local authorities. They were two different geographies, and actually one of them needed to be an invisible layer, and one was just the map showing. So what we had to do was marry the cumulative cases stats up with the map. And if we were to do that, we would have needed to create 342 different keyframes to ensure every day was accurate to everyday statistics. So, as you can see, the more keyframes I add, as you'd guessed, like the slower load time. And we transferred this over to a virtual machine. We thought that might kind of help us along the way. But actually, when you're loading thousands of points for every sort of day times 342, you can kind of see how that quickly draws so much computing power. And even with the fastest VM I could get my hands on, it still struggled because it was just so much data. So one of the trade-offs that we did have for this was, what we did was set the specific keyframes. So for example, on February the 1st, February the March, the cumulative counter date, statistics would be exactly correct. But then the pathway in between it would just calculate the average between those two dates. So, if you were to pause the animation at any given point, the likelihood it would be a roughly correct figure, but it wouldn't be exact. And that was, just a trade-off that we had, not having the resource to kind of, create all of these keyframes. And for me, not having the patience to sit there and wait for everything to load. So yeah, I thought it was just worth touching on that, because something I hear quite a lot is, cartography is a series of choices and compromises. And I think we can probably all relate to that. It's, we're never going to get exactly what we want. We always have to make those choices and compromises, whether that's color, whether that's technology or things like that. So without further ado, I think it's just worth showing you what we landed on. So as you can see, you can start revealing those different spatial patterns. As in the summer, it sort of died down, the numbers sort of decreased. And then as the schools and universities return, that then kind of flares up a little bit. And then the animation was only created up till mid-December. So it does stop there, but just kind of gives you an idea of the animation to that point. I would have loved to have updated it for today's presentation. I did try. There was a lot of different technical issues that I just had to walk away because it was just consuming too much time. So maybe I'll get around to it in the next couple of weeks. But hopefully that gives you an understanding of the project and the journey that we took. But yeah, any questions, I definitely welcome them.
Thanks, Sam. That was really interesting, actually. I love the way you showed how you've gone through an actual design process as well. So I'm just interested to hear, do Esri have like a set of design principles for map making that you guys follow? Because I know like Ordnance Survey do. We've got a set of principles that I just wondered if you guys have got a similar thing.
I think, speaking on behalf of Esri UK, I wouldn't say a written down formalized version of design principles. I think I guess because of my role and the nature of it, I'm working with such a sort of variety of data sets and topics. And I think for each one, there's a different sort of design approach to it. I think we definitely have, informal rules that we then follow, but no, not in the sense of sort of a strict design principles. I think, and not part of Esri UK.
Okay, fair enough. And the other thing was just an observation, really. I think you touched on it right at the start, where you said that obviously there were a lot of maps at that kind of early stage of the pandemic being released by different people. Some were horrific, not in terms of what they were actually depicting, but in terms of how they were made. But what was really interesting was that these maps evolved. And I remember seeing one from a guy, I think his name was Sam Joyner at the Times, I think. and he tweeted a map. I think it was using proportional circles, so circles based on the amount of cases, and he actually admitted that he had used the wrong kind of thematic mapping technique. He kind of said, it didn't work because those symbols started to overlap. So he did it again using like ridge lines, which showed, different heights depending on the amount of cases. And then of course he annotated specific areas of interest. So places like London or Glasgow where it was different. So it was interesting just to see that, although these maps come out quite early and people took kind of that kind of feedback on board and said, actually, I need to think about how I've represented that information. It's not probably the best way to do it. And have chosen to redo it. And I did find that really interesting, actually. So
yeah, I saw that quite a lot. People kind of revisiting maps and changing them and altering them. And I think that was a kind of a really healthy thing to have, where people weren't putting out a map and then sticking to it and never changing it. I think it has to evolve. And for all of us probably on the call, it's cartography is always the number one priority or up there. And I think for people like Sam Joyner who isn't a cartographer, it's probably not quite there. And I think forcing people to kind of think about the cartographic decisions they make, it's good to see that everyone is kind of taking the time to think about the design and what impact it has, especially when you're talking about like a sensitive topic like this. So yeah, it was really interesting to see.